In the previous video, we learned about private, public, and elastic IP addresses and how they are assigned to the ENIs attached to an instance. In this video, we are going to discuss subnets and route tables and how a route in the route table can make a subnet public or private. Then we'll talk about NAT instances and NAT gateways to give instances in private subnets access to the Internet. Subnets are separate portions of the VPC. EC2 instances must be launched into a subnet, so at least one subnet is required per VPC. To create a subnet, you have to define a CIDR block for it, which is a subset of the VPC's CIDR block. Every subnet in a VPC has to have a unique range of addresses. There can't be any overlap, or else there would be a duplicate IP address in your network. Now let's talk about route tables. For instances to communicate, there has to be a route that defines the path for the network traffic to take. A route consists of a destination designated as a CIDR address block and a target which defines the path to take. An example of a route would be a local route that allows communications to all instances in the local network, in our case a VPC. To communicate with instances in another VPC, you could define a VPC peering connection and define the peer connection ID as the target. To access the Internet, you could define an Internet gateway as a target. Every VPC will have a default route table with a single local route. This defines a route for instances inside a VPC to communicate with one another. You cannot remove this route, but you can customize the table by adding additional routes. You can create additional route tables and associate them with your subnets. This allows you to create what is known as public and private subnets. A public subnet would be used for instances that need a public IP to be accessible from the Internet. The way we make it a public subnet is to associate a custom route table and add a route to the Internet with an Internet gateway as a target. Notice that the Internet is defined with a CIDR notation as 0.0.0.0/0. An Internet gateway must first be attached to your VPC. If you don't have an Internet gateway attached to your VPC, none of your instances will be able to reach the Internet. A private subnet is used for instances that do not need to be directly reachable from the Internet. For best security, it's important to keep back-end instances and databases private, so those would go in a private subnet. A private subnet would be associated with a route table that does not have a route to the Internet through the Internet gateway. Even though private instances will not be directly reachable from the Internet, we will probably need to provide a way for them to get out to the Internet to download software patches and to access external services such as AWS's DynamoDB, a NoSQL database. To do this, we configure an instance in a public subnet to do network address translation, or NAT. A NAT instance will forward the outbound requests for the private instances to the Internet and send the responses back to the correct instance. You can easily launch a NAT instance by using an AMI with the correct network configuration. You can find these on the Communities AMI tab in the console when you are launching the instance. You will also need to add a route in the custom route table for the private subnet. For this route, you will specify 0.0.0.0/0 for the destination and the NAT instance ID for the target. There are a few things to watch out for when you use a NAT instance. One is that it is a single point of failure, so you will need to use some automation to monitor the NAT instance and recover it or fail over to a second NAT. Another issue is that the network bandwidth will be limited by the instance type and size. A better option is to use AWS's NAT Gateway service. AWS will manage the availability of the NAT gateway so you don't have to, and they provide bursting network bandwidth up to 10 gigabits per second. In this section on networking on AWS, we first explained CIDR notation, which we will use to define IP address ranges for our VPC and subnets. Then we covered public, private, and elastic IP addresses. We explained how these are assigned to elastic network interfaces and how they can be moved from one instance to another. Next, we explained dividing our VPC into subnets and using route tables to make subnets public or to give instances in private subnets a path to the Internet through a NAT instance or NAT gateway. In the next section, we will create a VPC from scratch and add additional security for our subnets with network access control lists. Then we will describe ways of connecting to our VPC.